Hi everyone, my name is Manvit Reddy and I'm here to propose my project on the EdnaML fake news under the subtrack of classification and labeling of a Twitter dataset using machine learning. So a little introduction to the problem. Fake news essentially stems from misinformation, and misinformation is extremely dangerous because it has the potential to actually contribute to social division. And through fake news, it can cause a huge divide in society. And coming to the problem at hand, since we're working with COVID-19 data, COVID-19 is obviously a huge virus that has taken over the world since 2020, and it has resulted in over 650 million cases and over 6.5 million fatalities. In the case of the pandemic, misinformation has been extremely disruptive in the sense that it has caused a lot of uncertainty and panic in what are the right things to do. And it has really hampered different health officials' advice and their capacity to respond to the pandemic. It leads to people having a sort of distorted sense of reality, leading to risky behaviors like not listening to medical advice, for example, not taking the vaccine or different things like that. So the motivation for this project essentially comes from the fact that finding this misinformation is not actually an easy task. It's quite arduous. And this is for a couple of reasons. First is because misinformation is constantly evolving, it's constantly changing with our time. And right now, it might be about COVID-19 being caused by 5G, but a week down the line, it might be COVID-19 being caused by anything or by a piano, for example. And since it's so ever changing, it can change topics, contexts, and words. It's really difficult to keep a track of. And of course, finding misinformation is also subjective because misinformation itself is subjective sometimes. And so now I want to talk about the new normal, which is how one of the papers described uh, how misinformation is in today's world. So they follow three different principles. One is novelty, which is the newness of the misinformation that keeps coming in and how it rises to prevalence. And then finally, ephemerality, meaning that it once it rises to prominence, it's quickly gone and the next thing comes up, and it's a huge vicious cycle of misinformation that keeps going on. So, what is the problem with the current classifiers? Firstly, they're static, which means that they are trained on a fixed data set, uh, basically. And secondly, this data set is usually constrained to a certain time period. So it doesn't capture the changing context and the changing topics of misinformation that we wish to capture in order to find all kinds of misinformation. And thirdly, it's also relatively tested on less data from basically a time period, from a certain time period. And then if the model is good, they say it's good. But in practice, usually those kind of models don't do well because they're not able to adapt and find newer kinds of misinformation. And our goal is essentially to identify misinformation from a large volume real-time stream, which is our Twitter data source, and constantly processing this data and finding out what kind of covert misinformation is spreading. So the data set is acquired from Twitter. So there are a bunch of tweets, and each of us is going to be assigned a month of tweets. And the information is gathered and uploaded to Azure, where we extract it. And the tweets are a very general source of data, and some of the JSON fields in it, for example, are like the ID, which is the unique identifier for the tweet, the full text, which is the content of the tweet, where it's created, how many retweets it has, how many likes it has, and there are a bunch more fields. These are just a few of them. So they contain a lot of information, not just about the content, but also about the user, when it was posted, and you can really get a lot of information just from the tweet object itself. So my approach and schedule to the project goes as follows. So in week 0, we plan on conducting data analysis for the month of January 2020, which is just a test data set. And we want to do this to basically identify and look at various metrics like what are the total number of likes, average tweet length, how number of punctuations. And this is honestly just to get an idea of what is the data that we're working at and what kind of data set we're working with in order to help us make decisions on what kind of models and what kind of clustering will be useful on such a data set and what kind of cleaning it also requires. Then we download models from Albert Transformer and import it to our G drive. In the second 2 weeks, we move on to the data set part. So now that we basically take our raw data set, which we refer to as FNC raw, we filter it using COVID-19 keywords handpicked by us. For example, like mask, vaccination, COVID-19, the word itself. And then using this, we create something called the FNC filtered data set. And these tweets are obviously directly connected to COVID-19 because they contain some crucial keywords about it. So most of them will be about COVID-19, and uh, if not all. And the remaining tweets, we call them FNC unfiltered. This doesn't necessarily mean they're not about COVID-19. And that's how in the following weeks, we'll try and extract the tweets that are related to COVID-19 from the FNC unfiltered data set, which is what we do in week 3 and 4. So now that we have a filtered data set with all COVID-19 data and an unfiltered data set, which we don't know which is COVID-19 and which is not, we basically use a technique called semantic masking to develop a clustering model. And we apply this first to our FNC filtered data set in order to get clusters on what are the relevant or prevalent topics that are being, or topics or clusters that are being formed in our COVID-19 only data set. And then we take these clusters and we apply the same model to the unfiltered data set to see what are the tweets above certain threshold that are falling into the COVID-19 kind of clusters. And we pick up those tweets and we add them together and we create a final COVID-19 related tweets data set called FNC extended, which will cover both tweets directly related to COVID-19 by keyword, as well as tweets which are related to COVID-19 but might not contain any explicit keyword. To handle edge cases in week 5 and 7, we basically train new clustering models on the data set. And then we're tasked with training a large language model on the extended data set, which is useful for capturing contextual information. And from this, we sample 500 points from the data set and essentially use it, human hand label them, and then use it for evaluation and validation. And then once we verify the performance of the model, we can collect statistics. And then I don't think the project necessarily ends there. It's more iterative. So if the performance is not good, we could potentially look at how our clustering is done or look at our language model and look for better performance. And then we cluster these data into latent proxies. So the project flow, as I described, I don't think it's going to be only going one way. It's definitely going to be a back and forth. So we start with our raw data, and then we're tasked with cleaning and processing it, which is obviously that a lot of techniques one can use. And then we take the cluster the COVID-19 tweets using the method I described in the previous slide. And then we use this to train our language model on the FNC extended data set. And then we evaluate if all things go perfect. But there are also fallbacks of if the evaluation is not good, maybe we go back to either training or cleaning. And if our clustering itself is not really looking positive, then we can go back to cleaning and processing the raw data immediately. The deliverables are basically three in number. So the 500 hand-labeled samples for the FNC extended clusters, the entire FNC extended data set itself, and the trained language model. Some of the meta skills I'm looking to develop in this project are, first of all, handling a large amount of data. I think handling a large amount of data is such a crucial skill to have, especially in this new data-driven world. And this project will help me gain more experience in that. Secondly, machine learning is also a huge skill to pick up. And this project involves some machine learning modeling. And because it involves both supervised and unsupervised, in the sense that we have classification as well as clustering, I feel like this is a good place for me to also learn a lot about machine learning and further improve my knowledge on it. And thirdly, I obviously want to improve my communication and presentation, and that's a big part of this project because I think it's not just important doing the work. It's obviously important to be able to communicate the kind of work that you're doing to your teammates, your mentors, and your professors. And that's why I feel like this is a big meta skill for me to pick up on this project. And fourthly, I'm also learning a lot about testing and evaluation, which is not something you often do in college because once you write code, you're done with it. But actually, going through it, evaluating it, testing it, rerunning it if necessary, are things I'm looking to learn and during this project. Fifth, I think collaboration is just part of every project, and it's like a extremely crucial meta skill to pick up for all kinds of projects. So that's one I'm looking forward to honing in this project. And lastly, I also think this project has a lot of timed variables, and there's a lot of deadlines to keep up to. And I feel like that's going to bring some punctuality to it. And I think that's one of the most important meta skills, is to be punctual, but also to deliver the right kind of work. And that's something I'm looking forward to learning in this project. So I thank you all for listening.